Hey, good morning, everyone. Now in this video, I'm going to talk about how to create virtual machines and containers on Data Lab. For this experiment, we'll be using this guide on containers uh, using Data Labs. And now, to create first we'll be creating a containerized experiment. For this, we'll be needing this .tcl file, which I've already downloaded over here. So we need to transfer this .tcl file from my local machine to the detail labs. For that, we'll be using FileZilla. And I've already logged into my username and passwords in FileZilla. So just drag and drop the example1.tcl file from here to here. So you can see that it's already been sent to the detail labs. Now we'll open the terminal and SSH into my detail labs. USC, enter the USC password name, username and password, sorry. So you can see that you're being logged in into the data labs. Now, to see if the file has been transferred from the local PC to this server, you can see ls, you can see that example1.tcl has been transferred over here. Now, to create a simple containerized experiment, we will copy this command. See, and just paste it over here. And we will give some other names because this example one would be already created by someone else, and we'll also give the directory ee542 space vir1 and hit enter. So we have to wait for like 1 minute and the experiment will be created. By the time we'll go into our data labs account. Okay, enter your username and password. Login. Now you can see that a virtual vir1 experiment has been created, and you can see that the container has been successfully created, and you can access, they have given the URL to access that, but we have the password. So if we go inside it and go into the visualization tab, we can see that only one physical node has been created, but to see the full topology, we can use this command, which I've already copied over here. Okay, it's not working somehow, sorry. We can go into the core lab and copy the command from here. This is the command which we are going to use to see the full virtualization, and paste it over here and just give it the var1.png and the experiment name which we created and for which you want to see this virtualized image. vir1 and just give the directory name. Okay, it's been created. Now you can see that in your FileZilla over here. Okay, we'll refresh it, and you can see that one.png has been created. So I will do this thing over here and has been created. So you can see that this is the virtualized image of the topology we have created. Here you can see that the 10 nodes have been created. With the 10 nodes have been created with the central router, and you can see all the links and the IP addresses of this network here. But when you go into the data lab, we will be using only one physical node to create such an experiment. Okay, now next we'll move into the other part of this tutorial. We have already created the containerized experiment. Now SSH into the nodes to see if the nodes that we have created will ping with each other. Now to log in to SSH into the nodes, we have to first swap in then the experiment, give the confirmation, and this will take like 10 to 15 minutes, and I'll pause the video and start when it is done. Now you can see that the experiment has been swapped in successfully. Now we'll go back into the terminal and we'll SSH into the nodes. SSH node 2, we'll try the experiment name that we have created. Oh, sorry, vir1 dot 2. Yeah, you can see yes, and you can see that we are into the node 2. Now we will ping from this node to the center we can if to check if they have the connectivity or not. Ping hyphen c 3 and center, because the name of the router in the center is center. You can see that the ping test, it is passing the ping test, and this also has the time to leave, number of packets lost, and all the details. And we can also check to the other node, ping dash c 3 and node 3. You can see that they are pinging each other. Okay. Now we'll be using the start commands. Start commands are the commands that help us to run a particular command when the experiment starts. That is, now I will create an output file which has all the details of the nodes which were accessed by the users. For that, we have to SSH into one of the nodes. We are already into one of the nodes. Now enter the command like akdir1, maybe akdir equal to, give the path name. This is e542 slash exp slash again and e542 slash startup. This is a keyword startup, and the directory has been created. Oh, akdry. Okay, and now we'll put this command. dir space the file name which we want to create. It's been created. Now to see if the log file has been created or not, we will go into the main user. So we'll log out from this. Okay, exit. Okay, now we are into the main users directory. Now we'll see if the directory has been created or not. You can see that directory has been created. Now we'll go into the directory. Okay, ls, and you can see the log file has been created. Now we'll see if what's there inside the log files. You can see that uh, uh, we have logged into the node 5 and the log file has been generated. Of the experiment, we will be doing how to use different container types. In the previous example, in example 1.tcl, we used the OpenVZ container type. Now we are going to use Chemo, a container type that container.py assigns to the node. We have to use a default container option followed by the parameters such as Chemo or OpenVZ. Now we'll try to run this command uh, using the Chemo container type. You can see that there is an error message being displayed here that a chemo container types can be used only with 7 experiment interfaces, but not more than 7. And the experiment and the network topology that we want to create is of 10 nodes, so chemo cannot be used for this kind of interface. So to check the chemo container type, we are going to use a So TCL file which creates only less than seven interfaces. So I've already downloaded the .tc example2.dcl which will create only seven interfaces, and now we have to transfer this from my local PC to the data labs. I'll do that example2.tc, yeah, and it's done. And we will go back of this node. Okay, now I think I've been logged out of the SS data lab, so I'll log in again. Yes, see to AE at users dot detail dot net. Enter the password. Yeah. Now copy this command. See, just change the experiment name you wanna create and the directory name. I'll be giving E542 space vir2. This will take a minute, and now we'll go into the data labs and we'll see if the experiment has been created or not. Oh, we'll refresh it and we can see that experiment has been created with VR2 named, which will use the chemo containers. We'll go inside it and see in the visualization tab what has been created. You can see one node has been created, and to see the actual virtualization image of the network topology, we have to run the command. This command, which I've already done it, and paste it. Oh, sorry, it doesn't seems to work, I guess. So I will go into the containers.editor and copy the command from here. This is the command. Now we'll change the name of the image vir2.png, and we have to give the experiment name for which we want to create it. This experiment name is vir2 and the path name. I think it has image has been created. Now we'll go into the FileZilla. We will copy from this to here, and we may see that it has been created. Now we can see that by using the chemo container type, we have created a network topology with less than seven interfaces. And you can see the visualization of all the nodes that has been created, all the physical nodes which are connected to a center node. And now, this part we will be mixing the different types of containers. Mixing containers is attained by attaching the attributes to the nodes. To demonstrate this mixing of containers, we'll be using example3.tcl file, which I will transfer from my local PC to the data labs. And it has been done. And now I will, in example3.tcl, we will explicitly set the container and node type of the each node. Now for this, I will be creating this by using this command. C default containers command control C, control V, and I'll change the name of the experiment to vir3 E542, and I'm going to give the name as vir3. And we will go into our data labs to see if it has been created or not. Refresh it, and we can see that vir3 has been created. Okay, this is going to take us a little more time. Okay. You can see that in the visualization tab, we have one physical node has been created, and to see the total Virtualized topology, we'll copy this command and just give the name as different name, which would be vir3.png, and give the experiment name for which you want this network topology diagram. In this case, the name would be vir3 and give the directory name. It has been created. Now go to FileZilla, refresh it. You can see that vir3.png has been created. Okay, now we will see this. Now you can see that this is a different network topology that has been created using the example3.tcl file. Here you can see that there are 11 container types and everything is a QEMU VMs. Now, I will demonstrate you a different type of different category of mixing the containers with example4.tcl, which I'm going to transfer from my local PC to this data test environment. It has been transferred. This mixing of containers will contain three different types of containers. One would be physical nodes, and the other would be VOS process, and the third would be QEMU VMs. We put in this example, we will put the physical node into the mix, that is the node 8 on the computer by setting its containers, and the node type 2 embedded P node. I will demonstrate you this using this command. Uh, this command which has this thing. Copy this command and just change the name. To space, and I'm going to give as vir4 for this experiment. We'll go to the tutor labs, my tutor labs, and you can see that an experiment has been created which is still new, so we have to wait for it. And I think it has been created successfully. Swap. Okay, here you can see that two nodes has been created, and the node 8, which we were talking in the previous sections, has been on the physical computer by setting its container node type to embedded P node. To see the virtualized image of this, we will go to this. Okay, so we'll change the name to vir4.png and change the name of the experiment to 4. Enter. It has been created. Go to FileZilla, refresh your FileZilla, and transfer it from here to here. You can see the PNG file has been created. You can see that two different topologies has been created with the there's node 8 being the different container type which uses P embedded P node, and this uses this is a physical node, and these are all the QEMU VMs which we created. So by this we can understand that we can mix the containers with different types of container images and different types of VMs. Be setting the OpenVZ parameters. OpenVZ parameters, the advantage of OpenVZ parameters is that we can set the OS flavor and the disk space which will be allocated to the each node. To see what is the type of OS which is running on your current node, we have to SSH into one of the nodes first. That would be SSH node uh, 2, node 3 maybe, vir1 dot E542. Yes, you can see that we are inside the node 3, and now we can use this command to see the type of OS we have. A. Now you can see that the type of OS which we are using in this node is Ubuntu 14.04. And now by using the OpenVZ parameters, we can change the type of OS we are using. Now I'll be trying to do with using Ubuntu 12.04.02. For this, I have to use this command. See, first I have to exit of this node. Okay, now we can create a new experiment, name that as vir5, and just give the path name. We can go into the data labs to see if the experiment has been created or not. You can see that vir5 has been created, and this may take a little time, I guess. Go into vir5. I think it's been created, and you can see the visualization over here. And now this is we have to swap in the experiment now. Confirm. This may take 10 to 15 minutes, so I'll pause the video and continue when it has swapped in. Now you can see that the swap in has been created successfully. Swap success. Now go into one of the nodes. SSH node 2.vir5 dot EE542. Okay, we are already in the node 2. Now we'll see the command if the Ubuntu has been updated or not. A. Now we can see that the Ubuntu, the type of OS we were using has been changed. It was previously 14.04. Now it has been changed to 12.04. Now to see the disk image that is by defaultly there in the nodes, we can use df-h. Now you can see that the default disk space is 2 GB, which is allocated to each node. Now to change this the size of the disk, we can use a command which will allocate the amount of GB you want to give to that disk, which will be allocated to the node. The command would be, this is the command. You will copy and paste it over there and just change the name of the experiment, vir6, and give instead of data lab, give EE542. This is the directory in which everything gets stored. 6. It will take a 1 minute to create the experiment. We'll go to our data labs and check if it has been created or not. VIR6 has been created and it's being running. It will take a moment to get swapped in. Refresh it. Yeah, it's swapped. And now here you can see the visualization of this thing. And now use the command df-h to see if the disk size has been increased. Now you can see that the disk size has been increased to 15 GB, which we specified in the command as 15 GB disk space. And hence, by using this OpenVZ parameters, we can set the OS type, the OS flavor, and the disk space, the disk size allocated to each node. Now, in the next part of this tutorial, we'll be gonna learn how to use the packaging factor. Till now, containerized.py program used to decide how many virtual nodes to put on each physical machine. But now by using the packaging parameter to containerized.py program, We can put fewer nodes or the desirable nodes on each physical machine as we require. Now we will copy this command. I'll to show how passing factor works. Control C. But instead of doing it on example 1.tcl, I'll be doing it on example 6.tcl because this has this TCL file will create 16 nodes with three subnetworks. I'll show you the visualization just in just a moment. EE542 VIR. What will we will give the name as VIR7 and create. Go to the detail lab and see if it has been created or not. My detail lab. It's created and it will take a minute to get swapped. It's getting swapped. It's been swapped, and you can see the visualization of the physical nodes that we have been giving. This is the visualization of the network topology that we have created. And now to see uh, the actual visualization image, we have to use this command. Control C, Control V. Oh, sorry, what happened? I have to copy this more carefully, I guess. Instead of example 6.png, we will give it name as VIR 7.png. VIR7, this is the experiment name for which I want to see the visualization, and give the directory name, which is EE542. It has been created. Now go to FileZilla. We have to enter our host name, C542AE at isa.titlab.net. You enter the username, which is this, password, which I can't tell in the video. It has been done, and you can see a PNG file has been created. We'll transfer it to here, and we can see virtual7.png has been created. I'm sorry, I will delete these files which were created earlier. I've deleted them. And this is the visualized image of the example 6.tcl, which we created by using a pass factor in it. The pass factor helped us to create uh, three containers with 20 nodes in each of this container. That is three 20 node subnet attached to a single central router. And this is a normal way of using the packaging factor, but there are special types of packaging factors which I'll be showing you now. Go to your browser, go to the tutorial. Now we can see we have created this 20 node subnetwork with a single router connected to a single router. Now I'll be using a keyword called passpack, uh, which will uh, which will help us to allocate a particular amount of nodes in each container. Mhm. Copy this command, Control C. V instead of example 6, I want to give it a name as VIR8 and give the name as E542. This will take a moment to get created. We go to our data labs, my data lab, and see if it's been creating or not. Yeah, it's been created. The state is new. It will pre-run and it will get swapped. Swapped. Here you can see if it's swapped. We'll see the visualization of this. So you can see just by using a passfac keyword in the command, the topology has been totally changed, and we are able to create three different containers, zero, one, two. I'll show you the visualization of this topology. I'll change the name to visualization 8, and we have to give the name of the experiment for which we want the visualization. It's created. Now go to FileZilla, refresh it, and now you can see that this is the visualized form of the network we have created using the keyword passback. Here you can see that there is a container which is created using 20 nodes, and there is a container created with 5 nodes in each container, and this is the node which has 10 containers in it, sorry, and this is a container which have 5 nodes in it. Exactly. But you can see that there are in this container we don't have 10 nodes exactly, because there is a software called Metis Graph software which sees to the it is graph partitioning software. It takes a graph and number of partitions and finds the most balanced partitioning that has roughly equal node counts in each partition. This is to this is very important because we have to see the traffic, and a lot of not networking problems will be created if this software is not there. And now going on, we will use a new term called because of this Metis graph, we are not able to create a container with the specified and the exact count of nodes we want in it. So we'll be using a keyword called as node only, which will help us to create exactly the number of nodes we want in a container. I think this is the command. Yep, this is the command. We will copy, Control C, go to the terminal, just paste it. Instead of giving this as this name, we will change the name of the file. That would be EE542 VIR 9. The experiment would be created. We go to the data lab and check if the experiment is created or not. My data lab, and check VIR. We have created it and the state is new. It will pre-run and it will take a second to just get swapped. Okay, and it's swapped. Now we go inside, see the visualization. There will be this different visualization of the network topology we have created by using just a keyword called node only in the command line while creating this node only. Now we will see the visualization of this container, that container environment we have created. By the way, this is a command which we use to get the picture of the visualized format, which will be created, which will be stored in our data labs, and then we copy this image from our data labs to our local PC using FileZilla. The image has been created. We'll go to our FileZilla, refresh our FileZilla, and just transfer it over here. It's been created. Now you can see that by using a single command, we were able to allocate the fixed amount of nodes in the containers. You can see we gave the command 0, 1, 1 and 20s. That means in the first container we should have 20 nodes, and this we are having 20 nodes, that is from 0 to 19. And in the second we have put to 10. So you can see that this is a single container which is connected to LAN one, which has 10 nodes in it, and the third one is 3, 5. This is 1, 2, and 3, which has 5 nodes in it. So just by using a node only keyword in the command, we are able to allocate specified number of nodes in each container. And there is also a keyword called pass size, which uses the help of the ratio to the number of containers and the number of nodes we want. I'll show you this command also in this video. Control C, go to terminal, paste the command. Sorry, paste it. Instead of example 6, we are going to give the name as VIR 10 E542. The experiment would have been created in the My Data Labs. My Data Labs. You can see via VIR 10 has been created. The state is new. It's pre-running. And it's swapped. We go to here, we see the visualization. This is something different to what we have created in passpack and node only. And now we will see the actual visualization using this command. The image has been created. Go to FileZilla, vir10.png. Here you can see that this schematic diagram or this visualization diagram is very much similar to the what we created in the node only, but this is just another way to create a desired number of nodes in a particular container. And we have almost done everything in this tutorial. And so in this video, we have learned how to create a container using Data Labs and how to use the start commands, how to use different container types such as Chemo, OpenVZ, OpenPro, and Process. We mixed containers, that is different types of container types. That is, we mixed, in an example, we mixed Chemo, Key, MU, and in one experiment, we used all the physical nodes, VOS, processors, and Chemo VMs. And we also changed the open visa parameters to change the flavor of the OSS and the disk space which is allocated to each node. And now in the last part, we discussed how the packaging factor will help us to allocate fewer or desirable number of nodes to each machine. As a part of this lab, we were given a .tcl file to convert into the VM version of the .ns file that uses schemo and uh, emulated network links. So for that, the file is this. This is the file which I'm going to transfer it to the Data Labs first using FileZilla. Uh, here is the file. I'll transfer it over here, and I will use this command which will create uh, the chemo container and the partition for this. This is the command which I'm going to use, which will create chemo container type for the TCL file what we created, and I'll give it over here. Sorry, this is not the command what we copied earlier. This is the command, Control C. Yep. Instead of example 2.c, I will be giving listing .tcl, and I will give a name as list1 maybe, and give, instead of Data Labs, give
EE542. And this will create a experiment with name list1 in my data labs. Yeah, you can see the list1 has been created. It's new, it's pre-running, and it will take just a second to get swapped. Yeah, it's swapped, and we can see there is only one physical node which are using this. But to see the actual visual virtualized image of this command, we have to use this. So I'll give you as list.png, list1.png, and give the name of the experiment. That is list1. Enter. It created a list1.png file. We will refresh FileZilla, and we can see list1.png has been created. We will copy it to our desktop. Okay, it's been saved in some other folder. Documents E542, and this is the visualized or virtualized image of the .tcl file which we executed just now.
That's it for this video. Thank you.